Hello, you are most welcome, ladies and gentlemen, to Real Impartation Moment on Tuesday Night Anatomy with Daniel Okwan. Today's section, we continue our journey looking at the integumentary system. And there's the fourth part, which I've tagged skin appendages or derivatives of the skin. And so, without much ado, let's set the ball rolling. So, we've seen that the skin is made up of epidermis and of course the dermis. Derived from the epidermis are certain structures, we call them appendages or derivatives of the skin, or we can also say accessory structures of the skin. And these structures, although they are developing from the dermis, the epidermis, they are growing toward the dermis, or even sometimes they get into the dermal component. And these things are what we call, yes, one of them I'm going to talk about now. We are going to have the sweat glands. We are going to have, of course, the hair. We are going to have the sebaceous glands. So this time around, I'm looking at the sweat gland. Now, the sweat gland, yes, will have a excretory unit, a excretory portion, distally. And of course, it will have a duct which will open into the surface of the skin via its pore. So there will be sweat pore over there. Now, one thing that we find is that we have two kinds of these sweat glands. Yes, typically, we know that we have eccrine or merocrine secretion. For merocrine secretion, through exocytosis, the product will be conveyed, from, of course, the excretory units onto the duct, into the duct. Then for apocrine, the apical portion, together with the excretory unit, will be part of the secretion eventually, or the apical portion of the cytoplasm and the cell membrane of the excretory units of cells will form part of the secretion. But studies have shown that whether or not it is apocrine or merocrine, yes, the secretion is the same via exocytosis, no loss of any apical portion. So please get to know that. So whether it is apocrine or merocrine sweat gland, their secretion, as we stand presently from studies, it is actually by what you call eccrine or merocrine secretion, no loss of apical cell membrane or cytoplasm. But what we find is that structurally, what we find is that for merocrine sweat glands, they tend to be confined to the dermis. They tend to be confined to the dermis. But for the apocrine sweat glands, they tend to go beyond the dermis towards what we call the hypodermis. The excretory unit gets into the hypodermis. And then again, what happens is that these glands, their duct tend to open into a hair follicle. Hair follicle. Then we've also seen that by way of control for the apocrine sweat glands, they will be controlled by the autonomic nervous system. But for merocrine sweat glands, they will be controlled locally. But what we find is that the secretion, the sweat, which will be coming from the merocrine sweat glands, will not contain odor. It will be coming from the areas like forehead, from your palm, from the feet, from these areas. But those ones which will be coming from the apocrine sweat glands opening into hair follicles, will be odoriferous, from the armpit, from the groin area, for instance. And we said that modification of these apocrine sweat glands in the ear, external ear, external acoustic meatus, external ear canal, we are going to have what we call ceruminous glands. We form ceruminous glands. And these ceruminous glands, yes, will produce what we call cerumen. That's the ear wax. But again, the skin in the breast, it will lead to what we call mammary glands. So mammary glands are actually nothing but modification of apocrine sweat glands. So it means it's coming from the skin. So that is what we have to actually know regarding these, sweat glands. Now remember that sweat glands, you may also call them, sudoriferous, glands, sudoriferous glands. There are a lot, we have about 2 million of these sweat glands. Now, one thing is that some people may want to actually, because they sweat a lot, we'll see that the sources of sweat, and I'll talk about that one. They may want to remove some of these sweat glands. We will see that, which may, sometimes such people may die out of what we call heat stroke. We will see that. So, what are the disorders that we find regarding what we call the sweat glands? One of them is known as hyperhidrosis. Now, in hyperhidrosis, people sweat. So if you sweat a lot, that is what we call hyperhidrosis. So because of that, there are some people, because of the activities they are engaged in, then they want to remove these kind of, sweat glands. For instance, in the armpit, they want to remove the sweat glands over there. And when that happens, if care is not taken, then such people may die out of hypothermia. A lot of heat will be built inside the human body. Because we know that after sweating, you have to use latent heat of vaporization to, of course, evaporate the sweat. Otherwise, what will happen is that leads to what we call cooling of the body. So if we are not sweating, then by way of sweating to cool the body, yes, we are not getting that, from that area. So you may die out of hypothermia. And that's basically what we call heat stroke. Okay, please get to know that. Hyperhidrotic individuals, the uncomfort thing is that they have to always be having a lot of handkerchiefs in their hands because they have to be cleaning their palms, because such people tend to sweat more in their palm as well as in the sole of their feet. Okay, these are the things that we see. But another thing that we find, okay, regarding disorders of these sweat glands is what we call anhidrosis. And anhidrosis is absence of the sweat at all. So that, yes, you don't produce any sweat at all. That is anhidrosis, absence of sweating. Okay, so it means that such people too, yes, hypothermia could be a problem for them. Then apart from that, there are some people, they will suffer from what we call, miliaria. Okay, for miliaria, what we are saying is that, yes, although the sweat is produced by the secretory unit, but the duct is what we call blocked. Okay, remember, now this one in miliaria, yes, the sweat has been produced. In anhidrosis, no sweat production at all. In miliaria, what we are saying is that the secretory units have made the sweat, but the duct to convey it onto the surface of the skin is blocked. It means that the sweat will be trapped in the skin or under the skin. Okay, so please get to know that. When that happens, then what we know is that it may result in something we call heat rash. Okay, especially during what we call humid weather, hot humid weather conditions. Actually, it may lead to what we call heat rash. So please get to know that. But even there's a fourth disorder which we call it bromiderosis. And for bromiderosis, it's associated with the apocrine sweat glands. Say that if the individual sweats, for example, in the armpit, in the groin area, then it becomes highly odoriferous. A lot of odor in there. That is what we call bromiderosis. Okay, so please get to know these are the main disorders regarding what we call the sweat glands. Now, so roughly in a day, yes, the average person will sweat roughly 500 mils of sweat. Like the sachet water that you take, 500 mils of sweat. Okay, averagely, if you are really actively doing something, on average, that's what you are going to produce. But that is why we are saying that if you are producing more, that is hyperhidrosis, especially in your palm, in your feet. If you are not producing at all, anhidrosis, then Miliaria, then that one too is there. Then bromiderosis, please get to know that. But remember that this perspiration is very important. Sweating is very important in thermoregulation. I've already told you that. So that what are we doing? We are going to use latent heat of vaporization, okay, to remove it from your body. So that if you are not, that one is not happening, if you are not sweating, then you may die out of what you call heat stroke eventually. So the next thing that we want to look at, after looking at the sweat glands, we go to what we call hair. Now for hair, it is highly distributed in several areas. Individuals who are hairy, yes, they tend to have a lot of hair. But there are some areas which will be devoid of hair no matter what. That's in the palm, in the sole of your feet, okay, in the vermilion border of your lip, okay. You don't have hair there, as well as the veruminal zone. You don't have hair. In some areas of what we call the external genitalia, for instance, if you talk about the labia minora, talk about the clitoris, if you talk about the glans penis, yes, you don't have hair over there. But most areas, okay, we are going to find hair around the body. What is hair doing? Hair is actually protecting and, of course, serving as an insulator. That is why I said that by way of protection, yes, it will, for instance, in the nasal passages, it will trap particulate matter so that they don't get into the airway. Then, even apart from that, by way of insulation, upon contraction during cool conditions, it will cause the hair to actually stand erect on the skin by way of trapping a layer of air to serve as an insulator. so that we reduce heat losses by what we call radiation. Sorry, by conduction actually. Then of course it will guard the entrance, the openings, various openings, right, against particles, as I said in the nose, for instance, nasal cavity. And it's also sensitive to light touch. So sometimes some animals may be running in your hairs on your skin, and you may be able to feel that. But we have three kinds of hair. In the fetal hair, okay, the hair in the fetal life, we call it lanugo. So lanugo is unpigmented. Please get to know that. Fetal hair is lanugo, is unpigmented. Then in the case of prior to puberty, it's also unpigmented. But that one, they are short, fine ones. We call it vellus. And then we have what we call terminal hair. And it's that hair that you are going to die with. So that's why we call it terminal hair. And for terminal hair, they tend to be long, coarse, pigmented. And they will actually be coming from what we call these kind of vellus. So please get to know the three kinds of hair that we have in the human body. Fetal hair being the lanugo type of hair, unpigmented. In the postnatal life, before puberty, the unpigmented one being short and fine, being the vellus. And of course, the terminal hair, the one we are going to die with eventually, will be long, coarse, and pigmented, which will actually be arising from what we call the vellus. So, having seen the hair, then let's look at some bits of important features, histologically regarding the hair. So, if we talk about the hair, you have what we call the roots, or let me say the bulb. Then we have, of course, the follicle, which is portion of it, and of course we have the shaft, which tends to appear on our bodies. The one we see is the hair shaft, but the one which is anchored is actually the root. Okay, and then of course we have some portion of the follicle also embedded. So one thing that we have to know is that if we look at the root of the hair, then what we are going to say is that we're going to have what we call the bulb. The root of the hair, we tend to have what we call the bulb over there. So you can see that area, those two things that we tend to see as if it's bifid, that bifid area. That is what we call the hair bulb. So the hair bulb is at the root or the base of the hair follicle, as we've said. And then one thing that we see is that surrounding this kind of, or let me say, enclosing an area, these kind of hair, the bulb, what they are doing is that they're enclosing an area over here. That's also connective tissue. That connective tissue moving into what we call the hair follicle is what we call the hair papilla. So that's the papilla of the hair follicle. Papilla of the hair follicle. And that papilla of the hair follicle will contain connective tissue. So there will be connective tissue over there. So that blood supply could get to the hair, okay, over here. So please get to know that. That's the papilla. Not only even blood vessels, even nerves could also get in here. But one thing is that we say that at the base, okay, the epithelial cells, we are going to have some kind of epithelial cells. At the base, epithelial cells, okay, form a layer of what we call hair matrix, okay? The epithelial cells over there form a layer of what we call hair matrix. So please get to know that, hair matrix. A layer of hair matrix. Now, it is this area which, of course, through proliferation, it will give rise to, of course, so more or less in the hair matrix, they are where you have the stem cells for the hair. Okay, so that's why we see hair will be produced. Because what is happening is that these cells will undergo mitosis and then they will push, apically, okay, out towards the skin. So anytime you cut your hair, yes, the hair will grow. Until this area where is the hair matrix gets eliminated, then what will happen is that always hair will have to grow. And that is why of late, some people who are not growing hair in certain areas, they want to take some kind of product which is going to stimulate the mitotic activity in the hair matrix. Okay, so please get to know that. Now, moving away from the bulb, and that's the bulb, or let me say the base area, then I'll go to this area apical to the base. So the suprabasal area, then I'm having this area which I'm able to identify what we call some areas of the hair follicle. So some areas of the hair follicle over here, which is surrounded this hair, what do you call matrix, apically, is what we call the what do you call medulla of the hair follicle. This is the medulla of the hair follicle. Now, one thing that we know about this medulla of the hair follicle is that it's forming the core. Okay, that's the innermost portion, forming the core of the hair follicle, and it will contain what you call keratin. But this keratin it contains is actually described as what we call soft keratin. Soft keratin. Please get to know that. Now, when I move away from this kind of hair, then I'm going to the medulla. Then I go to the what we call the cortex. So on either side, I have the cortex. That is why the cortex is quite occupies quite greater portion of the hair follicle compared to the medulla. Medulla will be very small, very little. I'll show you that. So surrounding the medulla, okay, will be what we call the cortex. So that if you take a longitudinal section, you can see as if you have two layers, one on this side, one over here. Okay, surrounding it. Okay, so this is actually a longitudinal section. This is what we call the cortex. But one thing we find with the cortex is that the cortex is thicker than the medulla. We will see that. And that one will contain keratin. But unlike in the case of the medulla, it will contain what we call hard keratin. Hard keratin. And that gives actually the stiffness to this hair follicle. It makes the hair follicle actually stiff. Now, when I move away from that, I'll get another layer, a very thin layer. Okay, this layer over here that you find, that is what we call the cuticle of the hair. Now, the cuticle of the hair, although it is thin, it is very tough because it contains what we call hard keratin. So please get to know that. It is beyond this cuticle that I'm going to get what we call internal root sheath. Internal root sheath. So compared to that, now this is internal root sheath. Then beyond that, I have a thicker layer of sheath known as external root sheath. Now, this internal root sheath, okay, will surround this kind of, hair roots. You can see it extends all the way to the hair roots, even apart from that to the proximal portion of what we call actually the basal portion of the hair follicle, not the apical portion, but the basal portion of what we call the hair follicle. It will surround it as well. That is what we call the internal roots, sheath. Then if I go beyond that, actually surrounding what we call the internal root sheath, that becomes what we call the external root sheath. But look at it. This external root sheath extends from the skin surface. So from all the way from the skin surface all the way to what we call the hair matrix. So as you can see, it will extend all the way to the hair matrix, and even beyond that, it will go towards what we call the bulb of the hair. Okay, so this is what we call the external root sheath. From the skin surface all the way, it will come beyond the hair matrix and even towards what we call the bulb of what we call the hair. So please get to know that. So that is what we call the external root sheath. Then if I move away from the external root sheath, I get what we call the glassy membrane. Okay, glassy membrane. This glassy membrane is nothing but more or less serving as a connection between, of course, the hair and of course the dermis. Okay, the hair follicle and of course the dermis. By so doing, it is more or less serving as, let me say, basal lamina of the hair follicle. Basal lamina of the hair follicle. So these are the things that histologically we are going to see regarding the hair follicle. There we are. Now, even in real time section, we can see these areas. These are the bulb of the hair. That's the hair papilla. Okay, then that's the matrix, the epithelial proliferation over the hair matrix. Then beyond that, we have what we call the medulla of the hair follicle. Then just away from the medulla, okay, we have what we call the cortical area, that's the cortex. Okay, then beyond that, we go to what we call the cuticle. Then from the cuticle, we go to the internal root sheath. Then of course, external root sheath. Then before we get to what we call the glassy membrane serving as what we call a connecting link. But actually, although not shown here, one thing that we find, okay, associated with what we call the internal root sheath, okay, is what we call Huxley's layer. That's Huxley. Someone's name is an eponym. Huxley's layer. That one is found actually between what we call Henle's layer and cuticle. So actually, if you see the cuticle, okay, so in this case, this is the cuticle. Beyond the cuticle, we are going to find what we call Henle's layer. And between the Henle's layer externally and the cuticle internally, we find what we call Hasley's, layer. Hasley's layer. So usually Hasley's layer, we tend to say that it is part of what we call the internal root sheath. Internal root sheath. Remember, Hasley's layer between what we call Henle's layer and of course the cuticle. So as we've seen, cuticle is made up of hard keratin, and it's actually having that kind of squamous, cells. You're having that kind of squamous cells, very important for protection. So I indicated that these hair follicles are associated with some smooth muscles, and these smooth muscles are what we call the erector pili muscle, or the erector muscle. So that upon contraction, okay, during cold conditions, then it causes the hair follicle, which we see on the skin, to stand erect, trapping a layer of air to serve as an insulator, minimizing heat losses by what we call conduction. But in hot conditions, then we need to lose heat. So what happens is that it relaxes, and of course the hair lies on the surface of the skin. So please, let's get to know that. So there we are. These are real-time sections that we find. Yes, these are the hair follicles we're talking about. Okay, these are the hair follicles, and then the shaft will eventually project, apically. Project apically. So as I indicated, okay, medulla will contain what we call soft keratin. Both the cortex and then of course the cuticle will contain what we call the cuticle and of course the cortex. Both of them will contain hard keratin. So as you can see, majority of it, you can see the cortex is contributing much, as you can see over here. Little cuticle, more cortex, little medulla. So that's what we see. Then, having looked at hair, then we want to look at what we call the sebaceous gland, another accessory gland or another appendage coming from the epidermis downward growth. That is the sebaceous. Sebaceous glands are actually made up of what we call, simple branch alveolar gland. Simple branch alveolar gland. Usually they are associated with hair follicles, or sometimes they will empty directly into what we call the surface of the skin to lubricate the skin. For instance, in the areola of the breast, yes, they will lubricate it so that yes, it will prevent what we call cracking as the newborn suckles from the mother. Now, these sebaceous glands, you can have an area like, for instance, even in the tarsal, yes, even we call the meibomian gland, or even the tarsal gland of the eyelid. Yes, they are there. Yes, we may also find it in the even the labia majora, labia minora. Yes, they are going to be there. Although labia minora is devoid of skin, is going to devoid of hair, it will have what we call sebaceous gland. But sometimes we find it in what we call the oral surface or the inner surface of the cheek. When you find it over there, then it becomes an ectopic gland over there, and that's what we call Fordyce gland. Now this one, what happens is that the mode of secretion is going to secrete this kind of oily substance known as sebum, okay, which will help lubricate. Its mode of secretion is what we call holocrine. So the entire secretory unit, what will happen is that degenerates. And then from the basal layer, what will happen is that yes, some new secretory cells will begin to form, okay, from it. So the entire secretory unit is sacrificed as the secretory product, together with the secretory product, and of course conveyed into the ducts onto the surface epithelium. Okay, so that's what we see. Now around puberty, this one is stimulated. Okay, mainly these sex hormones stimulate the production of the sebum by the sebaceous glands, or the activity of the sebaceous glands, and so that one will happen. What happens is sometimes it leads to what we call acne. Similarly, most commonly acne vulgaris. Okay, we tend to see that. Okay, so please get to know that. So looking at the next appendage of the skin in humans is the nail. So the nail are the distal aspects of these digits, either the toes or the fingers. We tend to see the nail. So the nail, what we find is that the free, okay, that portion which grows a bit, that free portion, okay, outward growth of it is known as hyponychium. Okay, beneath that is what we call hyponychium. And then the entire, okay, this hyponychium, tends to be, a bit pale. Okay, this area. Okay, this area tends to be, that's the free edge area, that tends to be pale, as you can see over here, because yes, of course, we don't have blood vessels, or we don't have the dermal vessels in there, so we don't see any, it appears pale. But the body, which is over here, is actually pinkish. As you can see, it tends to be pinkish because beneath we have a lot of blood vessels. But even beyond the body, we have what we call the lunula. Now this lunula is actually pale as well. It's pale because we have a thick layer of keratin over there, so we tend not to see this kind of pinkish appearance of those blood vessels underlying it. So that's what we see. Now, even beyond that, we have some folds. So this fold, there will be a fold over here. These are what we call the lateral folds. And then we also have what we call another fold over here. Okay, that fold is what we call the proximal fold. Okay, the proximal fold. And then just moving away from the proximal fold, we have this kind of elevated region over here, and that is what we call the nail vest. Okay, the nail vest. Then even beneath the nail vest, we have what we call the eponychium. Okay, the eponychium is there. So we have the nail, vests. We have what we call the the proximal fold over there, which will have the germinal matrix, so that the nail can grow, okay, back after you cut it. Then we also have what we call the eponychium, okay, around this area. Then we have the nulla. Then we have the body. We have, of course, the free edge over there, the hyponychium. But if I take a section, okay, through what we call the digits, where I can see the phalanx, okay, over there, then what will happen is that at this area you have what we call the nail plate. Okay, we have the nail plate, and this nail plate, okay, will be sandwiched by what you call a dorsal, okay, dorsal roof, and of course ventral roots, which are both part of what we call the nail fold that I was talking about. And that nail fold is actually the proximal nail fold. Okay, so please get to know that. And we said that yes, we are going to have the germinal matrix, okay, in over here, germinal matrix around where we have the nail fold. Then we also have this area, sterile matrix, also part of the what we call the nail bed. So this is actually the epithelium, and this is the matrix, the connective tissue part, okay, of what we call the nail bed. And it is the nail bed which will contain this germinal area, which of course, upon mitotic activities, it will help in growth of this kind of nail. Remember that nail is highly keratinized. It's highly keratinized, so that it can really, that's why it's very hard, having a lot of hard keratin. So in another view, very clear. Now there's a free nail area, okay, which beneath it we have the hyponychium. That's the body, which is pinkish. And then of course we get the half moon shaped region, which we call lunula. Okay, lunula or lunule. Okay, that's the lateral fold. Then we also have what we call the proximal fold. Okay, proximal fold will also be there. Then this area is what we call the eponychium. Okay, eponychium, having this kind of cuticle. Then we also said that we are going to have the nail matrix, which is part of the nail bed. Okay, nail bed. So that's the root of nail matrix. So these are the things regarding, of course, the nail. So remember that the nail matrix is there. The mitotic activity is always taking place. That's why upon cutting it, yes, in no time we tend to see it growing. So it means that if there's injury to, of course, the nail matrix, then of course growth of these, this kind of nail will be impaired. Now sometimes, depending on the way we tend to cut the nail, we trim the nail, therefore especially at the toe region, what will happen is that we tend to see that the edges of these nails tend to be growing, burying into, of course, the what do you call it, the toe. And when that happens, it's quite painful. The place may get swollen, okay, due to inflammation. Then what will happen is that for you to avoid this, then we are advised to actually cut it quite straight, okay, to avoid this pattern of growth. So these are the things regarding the appendages of the skin. I hope you find it helpful. I'm very grateful for your time this evening. Have a good night, and may God richly bless you.